Okay, so let's talk about rational functions. So here's an example of a rational function. We know that it is two polynomials that are divided, the quotient of two polynomials. So here are some different things that we have been talking about. So how to find a y-intercept. Okay, so the way that we find a y-intercept, remember that when we have a y-intercept, that would be the place where a graph crosses over on the y-axis. So that point is going to be 0 something, right? So the way that we're going to find that is that we are going to plug in 0 for x. Okay, so number one, the way that we find a y-intercept is we plug in 0 for x. So we could say f of 0 equals 0 minus 3 over 0 squared minus 4. So therefore, I have negative 3 over negative 4, or 3/4. So again, you always must write this in a coordinate pair. I can't express to you enough that if you just write 3/4, it is wrong. You need to give me a coordinate pair. Or if you just say y equals 3/4, that's a line. Okay, so my y-intercept of this particular function is y equals 3/4. Okay, so x-intercepts. How do I find the x-intercepts? Well, what do? For an x-intercept, I have to set the entire function equal to 0. So I'm going to say x minus 3 over x squared minus 4 equals 0, because I'm putting y in for 0. But if you remember, the way that I would solve this is that I will multiply both sides by the denominator to go ahead and clear that denominator, and then I'm left with just x minus 3 equals 0. So the truth about how to find an x-intercept is that you really can just set the numerator equal to 0 and then solve. So in this case, I get x equals 3. But again, please do not just leave it as 3. We know that the x-intercept must be 3, 0. So for this particular one, we have 0, 3/4 for our y-intercept, and then we have 3, 0. Okay, so next, how do we find the vertical asymptote? All right, so let me erase what I have thus far, and then let's talk about a vertical asymptote. All right, so I'm going to erase this in my pretty drawing. Okay, so for a vertical asymptote, I need to know what domains are restricted. So I'm looking for what x cannot be. Because if you think about it, if I have a graph, okay, so let me grab a picture of a graph here for you. Okay, so I got a graph for us. So we said here, so we solved for our x-intercept, and we said that it was going to be 3. So I'm going to go ahead and plot this. 1, 2, 3. All right, and then we solved for our y-intercept, and we said it was going to be 3/4. Okay, so 3/4 is going to be right about here. Okay, so that's what I have so far. Now, to find my vertical asymptotes, it's the area that x cannot be. Okay, so therefore, I'm now going to set the denominator equal to 0. So for my x-intercepts, I set the numerator equal to 0, and the y-intercepts, I just plug in 0 for x. Okay, so if I say x squared minus 4 equals 0, I could say x squared equals 4, and x equals plus or minus 4. So my asymptotes are going to be lines, so x equals positive and negative 4. So I have right here, this line is not being drawn very straight, but that's okay. Not perfect here. Okay, so that's what I have so far. I have my y-intercept, have my x-intercept, I drew my asymptotes, and so what two things must I always remember about functions? Well, here's the two things I need to remember. One, I need to remember that they are functions. Remember we said these guys are functions. So these guys are functions means they must pass a vertical line test. So when I start drawing it, it always has to pass the vertical line test. And remember that they hug asymptotes. Okay, so far I've only drawn in vertical asymptotes, but I need to remember that they do hug these asymptotes. Okay, so I'm going to end here for this one, and then the next video will continue where this one leaves off.